direct variation. And so direct variation is just y equals kx, where k is our constant of variation. Okay, and k has a lot, or x has a lot of names, but really this is just the independent variable. And y, that, what does that make y then, guys? The dependent variable. And remember, this is technically the output, where x is the input. If our function is a function, all right? And so now how do we identify direct variation? Well, let's look at an example. If I have a table of values, okay, and so this is really technically example number 1. I have 1, 3, and 4, and then I have 2, and I have 6, and I have 8. Let's compare y over x. Now the reason we're comparing y over x is if I take this equation, right, if I say y equals kx, and I divide both sides by x, I get y over x equals the constant of variation. Now what that means is that we're taking our input and just dividing it, or I mean multiplying it by a number. So direct variation means I'm going to have an input, multiply it by a number, and vary it directly. So x is the number that I'm plugging in. I'm multiplying it by k. Y will always be manipulated in such that way. So if I look at the y over x of these numbers, which is really my constant of variation, the first one I'm going to have 2 over 1. The next one would be 6 over 3, and the next one will be 8 over 4. Now if they all equal each other, awesome. Whatever that number is the constant of variation, which is what? 2. See how that works?
Yes. Yeah.
Any questions on that? What if I were to change this last number? What if I change this last number to 11?
It wouldn't work.
It wouldn't work because over here I would have 11 over 4. Does 11 over 4 equal 2?
No.
No. So I couldn't say that k equals 2. Does that make sense?
Yep.
All right, cool. Let's move on to example number 2.